Welcome back, everybody. Today we're going to look at solving inequalities using multiplication or division. So, multiplying or dividing each side of an inequality by the same positive number, a positive, produces an equivalent inequality. So, in numbers, what does that mean? Let's say that we had negative 6 is less than 8, which is true. Now, I want to multiply each side by 2. Okay, so 2 times negative 6 is negative 12. 8 times 2 is 16. We multiplied both sides by positive 2. So negative 12 is less than positive 16. This is true. And because we're doing the same thing to both sides, that's a property of equality. So I take the same expression, 6 is greater than negative 8 this time, and now I want to divide both sides by 2. 6 divided by 2 is 3. Negative 8 divided by 2 is negative 4. I divided both sides by positive 2. Same thing to both sides is your property of equality. 3 is greater than negative 4 is still true. So that's what it means by property of equality with positive numbers. We'll write in this algebra part in class. Let's try a couple. Solve each inequality and graph the solution. So I'm looking at number 1. This is x divided by 8. The opposite of dividing by 8 is to multiply by 8 on both sides. These 8's cross-reduce to 1, so I have 1x is greater than negative 40. Our solution then is x is greater than negative 40. To graph this on our number line, we have an open circle at negative 40 because our inequality is not equal to, then greater than is shading to the right towards positive infinity. For number 2, we have 3 times x. The opposite of multiplying by 3 is dividing by 3 on both sides. Negative 24 divided by 3 is negative 8. So our solution is that x is less than or equal to negative 8. If we don't like that x on the right side, we can flop it over. Just remember that your inequality has to open to the same value. Over here on our left side, it opens to the negative 8, and when we rewrote it, it still opens to the negative 8. Graphing our solution. This time we have a closed circle at negative 8 because it's equal to left, less than, left, less than, goes towards negative infinity. Even class periods do the even U tries of 3 to 6. Odd hours do the odd U tries of 3 to 6. All right, this time we're multiplying by a negative value. So the property of equality is still the same as what we looked at on the last part. The difference is when we multiply or divide by a negative, the inequality switches direction from where it was. So it doesn't change if it's equal to or not equal to. It just changes the direction that the inequality is opening up to. So let's try a couple. If I look at example 7, This is y divided by -3. The opposite of dividing by a -3 is to multiply by -3 on both sides. -3 times 2 is -6. We multiplied by a negative, so this inequality that was opening up towards the y will now switch directions and open up to the -6. These -3's reduce to 1, so we're left with 1y. Again, you can switch this around so that the y is on the left. Just make sure that the inequality is opening up to that -6. Graphing our solution, we have an open circle at -6. Less than is left, so we're shading to the left for less than, which is -infinity. For number 8, it's -7 times y. The opposite of multiplying by -7 is to divide by -7. These -7 simplify to positive 1y. This is going to change directions because we divided by a negative. And -35 divided by -7 is positive 5. To graph our solution of positive 5, we have a closed circle at positive 5 because of the equal to. Greater than is shading to the right towards positive infinity. For the last set of u-tries of 8 to 13, even hours do the even u-tries, odd hours do the odd u-tries. Have a great evening, anybody. We'll see you tomorrow.